In this video, I'm going to be showing you how to find the area of a rectilinear shape. So before now, we have been finding the area of just basic rectangles by multiplying the length times the width, because that's like an invisible array. Here, we have a rectilinear shape. So here's an example of one. And rectilinear just means it has all right angles, and then it is comprised of different rectangles put together. So that's kind of what rectilinear means. And I'm going to be taking you through the different steps to find the area. So the first thing you want to do is you want to make sure that you have all of the outside measurements, because those will help you find the area of the inside. So what I like to do is I just like to run my finger across every side and make sure I have the length for that side. There we go. So I have all of my outside lengths. We will have some rectilinear shapes that are missing side lengths, and then we'll go through some strategies for how to find that. But for this one here, we're just going to be focusing on finding the area. So we have all of our outside lengths. So now I'm going to break it apart into separate rectangles. So when you have a rectilinear shape, you can break it into different ways, and it'll still give you the same area. So for example here, I could break my rectilinear here and have a rectangle here and a little bit longer one here, or I could break it apart here. And you can practice doing that with your third grader and proving that it's the same area, it's just breaking it apart in a different way. So I'm going to go ahead and break mine here. So now I have a really large rectangle and then a little bit smaller of one. So I have found the outside lengths. I have broken apart the inside. Now I need to find the inside lengths of my inside rectangles. So I like to do it this way. So if I'm going to ignore this rectangle here, and I'm just going to focus here. And I want to find the lengths of these sides. And the way that I do that is I want to use the side lengths that they're safe to use. They haven't been touched at all. If you notice here, this one's not so safe because it was extended, and this one's not so safe because it was broken into. So I really want to kind of use these two side lengths because they're safe. They weren't touched, and so they're going to help me. So if this side length here stayed the same the whole time, it was never touched, that means the inside rectangle is 8. And then I can use what I know about rectangles, that if this side length is 8, the opposite is also 8. Okay, so it's no longer 10. It's actually being broken up into 8, and the rest of it is over here. But we're going to ignore that right now, and we're just going to focus on this rectangle. So we have 8 and 8. And then I'm going to go here and I'm going to say, well, this one is a safe side. It wasn't touched. So if the outside stayed the same, that means my inside length is 6, and I can shoot that length all the way over to the opposite side. So now that I have all of my inside lengths, and they make sense because opposite sides on a rectangle are equal. If you find side lengths and the opposites are not equal, you should not continue, and you should reverse and figure out what happened, because opposite sides in a rectangle should be equal. So now I can find the area of this rectangle. I can multiply 6 times 8. So 6 times 8 is 48 square units for this rectangle here. Now I need to go over here. So I need to look at my safe sides. So here, this one didn't really even exist before I broke it up, so I can't use that one. And this side, again, was 10, and I broke it up. So I'm going to go with my safe side here of 2. This wasn't messed with, so if this is 2, the inside is 2, and then I can put that right over to the opposite side is also 2. This side, and if you look, it makes sense because it was 10, and it broke apart into 8 and 2. But if I put them back together and erase this, it would go back to 10. So these should add up to the original length. And then here, this side here was 3, and it stayed 3. Nothing happened to it, so I can use that. And then I can push that on over here to that. And again, I have opposite sides are equal because that is an attribute of a rectangle. And then I can kind of check it by thinking, well, if I measure this whole thing, 3 plus 3 should equal the length of 6. So it makes sense. You can kind of check it that way. So anyways, now I'm going to find my area of this rectangle. So it would be 2 times 3 is 6 square units. But remember, I'm trying to find the area of the entire rectilinear shape. So I need to now add these two together. So 48 plus 6 would give me 54. Now 54 is just a number, but if I'm looking for area, I need square units. If I had feet here or inches here, then I would have a certain unit. So use this strategy when you are finding area of a rectilinear shape at home. I really recommend that the students label inside, because if you're not careful, you have a lot of numbers going on here, and I might accidentally use this 10, or I might accidentally use this 6 when I shouldn't be. So I like to really just make sure that all of my things are where they need to be and I'm using the right numbers, because you're breaking some numbers apart. So you just have to be careful. So I hope this helps you finding the area for your rectilinear shapes on your homework.